All right, so today we're talking about permutations and combinations, which is one of my personal favorite topics in Algebra 1. So, kind of building off our fundamental counting principle and our factorial, permutations and combinations are just things that we use or formulas that we use in order to count the number of ways an event can happen. So that's really what we're focusing on, just figuring out the number of ways, the number of possibilities that there are for a specific situation. So looking at permutations and combinations, here's the difference. Permutations, order matters. Permutations, permutations are like passwords. Okay, the order matters. So if my password was dragons19 and I typed in dragons91, my computer wouldn't let me in, right? Because 19 and 91, they're different. The order matters for that password. Combinations, order doesn't matter. We don't care. Combinations is like if you go to a fast food place and you get a combo meal with like a hamburger and french fries and a pop. It doesn't matter if you get a hamburger, french fries, pop, or french fries, hamburger, pop, or whatever order you ask for it in, you're still going to end up with the same food in the long run. So the order does not really mean anything in that context. It's just the particular combination or group of items that matters. So we're going to look at these two things today. Now, here are the formulas for permutations and combinations, and we'll look at those in a second, but we're actually going to end up using Desmos to evaluate these. So we're going to start off by focusing just on permutations. So permutations kind of stem from the idea or question, what if the fundamental counting principle is taking too much time? And so this is, again, it's another shortcut. And so a permutation is an arrangement of objects in which the order is important. So we're going to end up using Desmos. So I'd like you to practice this. I know that you have like your notes in the video now, but at some point practice this. But here are the steps. We're going to open Desmos. Then you go to Functions and to Stats. And then towards the bottom, there are these NCR and NPR options. So you're going to use P for permutations and then NCRC for combinations. And then you type your numbers in with a comma, and that tells you your different answers. So I'm going to open my Desmos here, and then I'm going to split my screen with my calculator in my document. All right, here we go. Then when I type on it, notice I have my functions, FUNCS. I go to stats, and then towards the bottom is that NCR and PR. So we're going to practice with permutation. So P for permutation. So here's my NPR. And then for letter A, if I have 11 permutations of 8, so I have 11 items, and I want to make different orders of 8 of those items, I'm going to type in 11, comma, 8. Notice that if I just type in 11, 8, it doesn't do anything because it thinks it's just one number. So 11, comma, 8 tells me that there are, oh, that's my wrong pen. Okay. There are 6,652,800 different permutations. If we have, let's see, go back to functions, NPR, 24 permutations of 5. That gives us 5,100,480 different possible permutations or different possible orders. So we're going to use Desmos to evaluate those things. Now let's look at a couple of real-world situations so we can figure out the number of possibilities. Letter C, there are 15 people on the baseball team. Since the order they hit in matters, how many 9-person batting orders are possible? Now, I don't know what you know about baseball, but the order matters. If you don't bat in the correct order, you get in trouble. So our job is to use the information, use the numbers they gave us in the problem, and then type it into Desmos so we can figure out our answer. So when we're looking at this, for our N and our R, N represents the total of what we're looking at, and R represents the number we get to pick or we get to choose. Okay, so that's what we're looking at in situations. So for letter C, we have 15 total, and out of those 15, we're picking 9. So we want 15 permutations made up of 9 people. So I'm going to type that in. Here's my NPR. Here's my 15,9. That tells me, and this is in scientific notation, so what it means is that we're going to take the decimal 1.8162144 and multiply it by 10 to the 9th, which really just means we're going to move the decimal place over 9 spots. So here's 1, 2, 3, 4, 5, 6, 7, and then 2 zeros. All right, let's look at this. So this is 1,816,214,400 different batting orders. And that's if only 15 people are on your team. That's how many different batting orders there are. Okay, and so that's what we're doing. That's what we're doing with permutations and combinations. We're just figuring out the number of possibilities. Letter D, we want to change the password on our phone to a 4-digit code, but we can only use the numbers 0 through 9, and we want to figure out how many passwords are possible. Well, from 0 to 9, there are 10 numbers, right? Because we have the numbers 1 to 9 and then 0, so that's 10 different numbers or 10 different digits. And we want to figure out how many passwords are possible. So since we want to use different numbers, we have a total of 10 numbers to pick from, but we want to pick 4 different ones. So we're going to do 10 permutations of 4. So if we have 10, 4, that tells us that there are 5,040 different passwords on our phone, and that's just using individual numbers for each one, right? Not repeating any numbers. All right, so that's our permutations. Our order matters in those situations. Let's switch gears and look at combinations. So combinations, remember, order does not matter. We do not care about the order. It's like that combo meal. So now when we're using Desmos to figure this out, instead of NPR, we're going to use NCR. So go to your functions, stats, NCR. So 11 combinations of 8, so 11 items, and we want to pick or make combinations of 8 of them. We have 165. If we want to do functions NCR, 24 combinations of 5, that would be 42,504 different combinations. Notice that these numbers are a lot smaller. So since order doesn't matter for combinations, there are going to be a lot fewer possibilities. All right, let's look at a couple of real-world examples with our combinations. So we're playing kickball, and you get to pick 6 out of 12 people for your team. And how many ways can you choose 6 people for your kickball team? So thinking about this situation, the order doesn't really matter, because it doesn't matter if I pick Sarah and then Ted and then Jessica, or Jessica and then Sarah and then Ted, because at the end of the day, those same people are going to be on my team. So it doesn't really matter what order I pick them in. So we have a total of 12 people to pick from, and we're picking 6 teammates. So we're going to figure out 12 combinations of 6. Here you go, 12, 6. Tells us that there are 924 different ways just to pick the people on our kickball team. It's a lot of different teams, right? You could pick a different team every day of the school year and you still wouldn't get through all of those options. Letter D, you get to pick 3 different ice cream flavors out of 11 from the menu. How many ways are there to pick 3 different ice cream scoops? So we have a total of 12 different flavors, and we get to pick 3. So 11, 2 combinations of 3. Here we go, 11, 3 tells us that there are 165 different ways just to order our ice cream. So if you've ever been indecisive when you were ordering ice cream, now you have an excuse. You can say, well, there are so many different options. How's one supposed to pick? Okay, and again, that's what we're looking at, just figuring out those possibilities. All right, so we've talked about permutations. We've talked about combinations. So let's look at them together. The difference between permutations and combinations is that a permutation is an ordered combination. So they're very, very similar. It's just a permutation, the order matters, a combination, it does not. So for if we look at the word bat, there are 6 different permutations of the word bat, but there's only one combination of the letters B-A-T. Because it doesn't matter if it's B-A-T or if it's T-A-B or A-B-T, because they're the same combination of letters. And that's the difference. Permutations All of those different orders matter. Combinations, we don't care what order they're in. We just care that they're letters B-A-T. All right. So we want to be able to look at a situation and figure out if it's permutation or combination. So that's our next step. So 6 people are running a race. First, second, and third place get a trophy. And we want to figure out how many ways can first, second, and third place be awarded. So our first question, is this a combination or a permutation? Well, when you're trying to figure that out, you should ask yourself, does order matter? So does order matter for first, second, or third place? Okay. If you're on the fence, let me phrase it a different way. Is there a difference between first and third place? There is, right? I mean, if you're running your race, you want to get first place because that's first. The order does in fact matter. So since the order matters, this is a permutation. Because remember, permutations like passwords, the order matters. So since it's a permutation, we're going to take our 6 people and we want to award the first 1, 2, 3 places. So we're going to take 6 permutations of 3, and that's going to be our answer. Function permutation 6, 3. Oops, I forgot my comma. 6, 3 tells us that there are 120 different possibilities. There are 120 different ways that race can end. All right, let's look at one more. You are taking a history test and you need to respond to 2 essay questions from a list of 6. And how many ways can you complete the exam? So let's think about it. You're taking your history test and say you do the question about World War II before you do the question about Waterloo. Does it matter? I mean, as the teacher, does it matter to me? All I see is that you completed both questions. So it doesn't really matter if you complete like question 1 and then question 4, or question 4 and then question 2. That doesn't matter in the long run. All that matters is that you complete a combination of 2 questions. So this is combination because in this instance, that order doesn't mean anything. Order does not matter to us at all. It doesn't tell us anything. It doesn't change anything. It's really inconsequential to this situation. So we're going to do a combination. Well, there are a total of 6 questions, and we want to pick 2 of them. So we're going to do NCR, so function NCR. Now, always put your larger number first. If you're on the fence about which one's N and which one's R, the larger one has to go first. Because look what happens if I do 2, 6, 0. Okay, so anytime if the N is, that is basically saying that we have 2 numbers total and we want to make combinations of 6. Well, we can't do that, right? If you only have 2 items, you can't make combinations of 6. That's not how life works. So just keep that in mind. The larger number does need to be first. There are 15. So there are 15 ways that you can finish your history test. That's a lot of ways. So this is our combinations and our permutations. All we're doing is figuring out the number of ways something can happen. And the main thing you want to remember is that for permutations, they're like passwords, order matters. Combinations, it's just that particular combo or group of items, and the order does not matter whatsoever. Remember to complete your assignment and then submit when you are